Alright guys, one of the things that we need to cover is how to convert from one kind of unit to another. So this will be a short video on unit conversions. What we really need to do is, within the realm of like science, you're going to be able to get various kinds of measurements from tools, and sometimes that measurement is maybe not in the unit that is most convenient. So we have a system and kind of a way that you go about converting things. I'm just going to give you guys some simple examples here so that you guys can see how it is we go about converting things. Here, let's go with this first example that's really simple. Mr. Parson is 71.5 inches tall. In this particular case, inches is the unit of measurement that we're kind of used to here in the United States. Well, for the most part, the rest of the world never really talks about inches, so it's kind of useless. What we'll need to do is we'll need to convert it into a unit of measurement that makes more sense to kind of the rest of the world. So what we want to ask is, how tall is Mr. Parson in centimeters? This is the new unit that I need to go to. So here we are starting in inches, and we need to go to centimeters. In doing this, what we have to find is kind of like a path or a route to do this. So I know that my plan here needs to be, I've got 71.5 inches. That's what they give me. And I need to go from the realm of inches, and then somehow I need to wind up with the number in the realm of centimeters. What we have kind of set up here in just creating this very simple plan that I've made right here, here's our given value. This is some kind of measurement that was made in evaluating how tall Mr. Parson was. And here we need to figure out, all right, well, what does this number look like when it's been converted into centimeters? We need to find a path from inches to centimeters. We have a file that we'll be sharing with you that has a number of these conversions. So you guys can see here, it's got a ton of information. If I completely zoom out here, you can see that this is like a full page kind of document that has just tons of information about one measurement being converted into another. So here's what I'm seeing in this section. I do see centimeters and inches. So I should be able to kind of figure out how to go from one to the other. So what I'm able to do with this kind of table is I see this. I see that in terms of inches, 1.000 inches has a conversion to 2.54 centimeters. That conversion that I got from that table is 1.000 inches is equal to 2.54 centimeters. I now have a what's called an equality. That all that really means is that something is equal to something else. You can think of a number of different equalities, like 1 dozen is equal to 12, $1 is the same as 4 quarters, 1 foot is 12 inches. Those are just different kinds of equalities. Now we need a tool that actually helps us kind of do this conversion. If you've taken a science class before, you may have seen this kind of tool before. This is called a t-table because it kind of looks like a T. What we do is in the first box here, so in this location kind of right here, you're going to put the number that you have, whatever you've measured, whatever value you're given by the situation or by the experiment, that's what goes there. In this case, that is 71.5 inches. So I need to take my 71.5 inches, and that needs to end up in this first box down here. Now, usually whenever we start this kind of thing, the box immediately underneath, we're going to more or less disregard. I'm not really going to put anything there. If you want to just put like a filler or something, you can put a star, you can put a smiley face. Since we're doing math, you can put a sad face. It's like crying. Anything you want to put there, you can put there. So I like to make myself smile while I do math, so that's what I'm going to put there, just kind of a filler. And then in this next section here, these two boxes, this is where we're going to put the equality. So this information I'm going to arrange in a way that makes sense in these boxes here. Ultimately, I need to not be in inches, and I do need to be in centimeters. So in order for those inches to kind of go away, I need them to, cancel out. What we can do is just kind of do a simple math problem here. If you had something like 7/3 and you were multiplying that 4/7, the way that we could simplify this problem very quickly is the 7 is being divided by this 7. So 7 divided by 7, they cancel out. This 7 kind of gets canceled out by this one. So our very quick answer then would just be, 4/3. So in that same kind of thinking in making things cancel out, we need to make sure that our inches cancel and we're only left with centimeters. The way to do this is to put inches down below here. So what you'll always tend to do with these t-tables is in the prior box, it'll have whatever unit you kind of started with, and you'll always want to take this unit and copy it diagonally into this place. That's the only way that you'll get these to cancel out. Then we end up with the unit that we want. The unit that we want goes on top because it will not be canceled out. So now what you guys can see is this is the equality, right? We're creating a thing over another thing where centimeters and inches are related. Now that's when we kind of build in these numbers, and that's where these numbers are going to go. For inches, I'm going to put the number that's right next to inches, 1.000. And then in the case of centimeters, 2.54. Now, I actually need to do this calculation, 71.5 times, and that's how you read this. Going across, you multiply. And then anything that is down below, you divide it by. It's just another way of representing fractions, but in a t-table, it's a little bit easier to kind of manage, and it helps you keep track of things. So inches, we'll cancel inches, and I need to do 71.5 times 2.54. 71.5 times 2.54, 181.61. And now we're in centimeters because our inches have canceled and centimeters is the result. I do need to keep track of significant figures from my original value. The 71.5, just looking here, this is a non-zero, this is a non-zero, this is a non-zero. That has 3 significant figures. In terms of significant figures for equalities, so remember that this is our equality right here, the 1.00 is equal to 2.54. That came from that sheet, that conversion sheet that I showed earlier. This does not have any sig figs at all. We actually have to kind of disregard those. So really, our sig figs are going to be based on just kind of the number that we started with. Okay, 3 sig figs, 1, 2, 3. And then I'll end up cutting this number off kind of right here. So the number that I should report with the correct number of sig figs is 181 centimeters. So to answer our original question of how tall is Mr. Parson in centimeters, I can say 182 centimeters because when I kind of cut this number off here, this 6 will cause that 1 to round up. So really, the correct answer is 182 centimeters. Let's do another quick example. In this example, we're going to talk about Mr. Parson again. We're going to use another kind of measurement. In this example, Mr. Parson weighs 75.00 kilograms. Now, in the case of kilograms, that's actually what a lot of the rest of the world uses again. So that is a value that makes sense to most people. However, for us, we kind of wouldn't really know whether that's heavy or not. So what we'll need to do is we'll need to kind of convert this into the number of pounds. So how many pounds is Mr. Parson? Once again, we're going to run this example more or less just like we did with the prior one. I need to go from the 75.00 kilograms that I'm given here, and I need to figure out the number of pounds. And just like before, what I need to find, I'm starting in kilograms, but that's not what we want, and I need to go to pounds. So I need to see if there is a direct way to go from kilograms to pounds. And already I'm starting to see that there's a couple of things further down here. I'm starting to see, all right, there's kilograms, there's pounds. Let's see, which one do we want to use? Let's use this top relationship. 1.00 kilograms, 2.2046 pounds. I'm going to take those numbers and go over to what we were working on here. 1.000 kilograms is equal to 2.2046 pounds. Okay, we'll set up a t-table here. The value that we start with that has the units we don't want, that needs to go into our very first slot here. 75.00 kilograms goes right here. Underneath this, we really don't want to put anything. So I'm going to be putting my placeholder, my smiley face. And over here, I'm going to put, remember that I want kilograms to go away. I want this unit to cancel out. And in order to make that work, I need to copy that same unit to kind of go down here. So kilograms will go down below, and the unit I'm heading towards will go on top. Now I just kind of fill where those numbers go. So right up here, right next to the pounds, I'm going to copy the value that we got from that table and put it here. And then the value that is right next to kilograms needs to go next to where we have our kilograms. So in this case, we're going to be multiplying across the top 75.00 times 2.2046 pounds, 165.345 pounds. Remember, our kilograms here is going to cancel out with our kilograms there. One of the things that I kind of failed to mention in the first example, but I'm going to try and mention it a little bit more clearly here. In both the first example and the second example, if you guys notice, we're dividing by 1.000, which when you divide by 1 does nothing to the number. So that's why in this case, all I'm really caring about is the 71.5 times 2.54. And that's how I got my answer here. Same thing is actually happening in our second example. All I need to do is multiply the 75 and the 2.2046. By dividing by this value 1 down here, I do not change my number. Okay, once again, I need to care about sig figs. I see a 7 and a 5. Those are non-zeros, so they're very easy. Yep, they're totally sig figs. And now I've got a weird situation. I have 2 zeros here and a decimal point, and they are to the right of that decimal point. If you guys remember from our previous videos about sig figs and scientific notation and stuff, these zeros are actually significant. So my original value is 4 sig figs. That means my ending result needs 4 significant figures. Kind of saw off my number there. And then the final value I can report, 165.3 pounds. And I believe if we look up here, that answers our question. How many pounds is Mr. Parson? There's our answer. In this case, we're going to try and give you an example that is a little bit more complicated. In example 3, we're going to be talking about our daily H2O needs, like how much H2O we need to actually drink. According to some sources Mr. Jordan and I found, the average human needs to consume 3.70 liters of water a day, plus or minus a smidge. Now we're going to throw a unit at you that you probably have never heard before, and I say that because Mr. Jordan and I barely have heard of this unit before. But we want to show you guys what a crazier kind of strange conversion is. How many hogshead is it? And everyone's like, did you really say hogshead? Yes, I did. So we need to make a plan. We need to go from the original value of 3.70 liters, and I need to go to the world of hogshead, which is some crazy unit of volume. Now this one is going to be more challenging. I'm going to scroll up here to our other examples. Here we went from kilograms to pounds, and on our conversion sheet, I had found a direct conversion, straight from kilograms to pounds. In the other example, we were going from inches to centimeters, and that's a common enough conversion that they have an exact kind of conversion. You can go straight away from inches to centimeters. There's nothing in between. What I'm going to preemptively kind of warn you about here is if you go to our conversion sheet, which I'm going to pull up here, and if you do find yourself looking at hogshead, this is hogshead, you'll see that hogshead appears on this conversion sheet once, and the place it goes is barrels. Well, from barrels we cannot go straight to liters because a barrel is equal to some number of gallons. And then if we look down here, liters can be converted in relationship with gallons. Holy moly, we're going to have to go through many qualities. We're going to need to use 1, 2, 3 different equalities in order to make this happen. So let me improve on my plan here. The current plan that I've got here, just going straight from liters to hogshead, not exactly the story that's true. Here's a more accurate story. I'm going to have to go from the 3.70 liters to gallons, and from gallons I get to go to barrels, and then finally from barrels I can go to hogshead. And remember from that prior document there, the conversion sheet, I'm going to need 3 different equalities. So every one of these arrows here is an equality that I'm going to have to use from that prior place in order to actually make this happen. Our various conversions that we're going to need, I'm going to use a different color here. 1 liter is equal to 0.2642 gallons. That's one equality. And then from gallons, I can go 31.5 gallons is equal to 1 barrel. That's our second equality. Now our final equality is from barrels to hogshead. 2 barrels goes to 1 hogshead. Okay, there's all 3 of our equalities that we're going to need to actually make this conversion happen. Our t-table is going to have to be a little bit adjusted. For every one of these equalities that we're going to use, we're going to need to extend our t-table. Depending on some of your prior science classes, you will have heard that this then stops kind of being a t-table, and it will look a little bit more like railroad tracks. And as I kind of draw this out, you'll see why. It starts to look like an overhead view of railroad tracks. So now I need to start building my conversion here. The 3.7 liters is the amount of water we have to consume every day, and that's what was given to me. So it needs to go in that first spot, and nothing really underneath because that's just kind of our placeholder. Next thing I need to do is I need to make sure my liters cancel, so my liters need to go in the diagonal spot here. And my first conversion, if I look up here, is going to be liters to gallons. And that will help me cancel my liters now. And I can fill in this info. So there's 1 liter. So I'll put 1 next to liter. 0.2642 gallons. I'm going to cross out liters and liters. We're kind of in a point where this is a little bit new territory. We're going to continue here. So I need to take my gallons, and I need to do the same thing. Those need to cancel. The gallons is still not the right unit. I need to go all the way to hogshead. So I'm only right here kind of in like a terms of steps. We're in like step 2 going into step 3. And we have a ways to go yet. So I'm going to write gallons down here. And the second kind of equality we're using, we'll put barrels up here. I have no idea what a barrel is, but apparently it's 31.5 gallons. Now I'm seeing gallons cancel with gallons. I'm going to copy in those numbers. 1 barrel is 31.5 gallons. I'm going to kind of speed through this last little bit here. Barrels needs to go down below. Hogshead need to go up above. Barrels will cancel with barrels. So all of our units here, if you look, liters, gallons, barrels, everything is canceling except for hogshead, which is what we want. It's a really good way for us to verify that we're kind of doing our work correctly. We're ending in the place that has the right unit. 2 barrels, 1 hogshead. This example differs than our last one. We're going to multiply all the numbers on top, and then I need to divide by the numbers that are down below here. So these, I almost need to treat these down here as if they're in parentheses and multiply them. And then this number down here, we're going to divide by. Step 1, we're going to take 3.70 times the 0.2642 times the 1 times the 1. 3.70 times 0.2642 times 1 times 1. 0.97754. Now I need to do the same thing but across the bottom. I'm going to multiply 1 times 31.5 times the 2. 1 times 31.5 times 2. That's 63. And now you need to divide. So final step here is dividing 0.97754, and then we're going to divide by 63. So that value is going to be 0.0155. Our original value has 3 sig figs. So my answer is going to be adjusted to have 3 sig figs. So the final answer here is 0.0155 hogshead.